Thank you, Judith. We're talking about utilizing a research-based rubric to assess students' creativity, specifically improving. And we believe that this kind of environment, the IBL environment, would foster such type of discussion. So let me give you a little bit of background literature on creativity. Eric Mann in 2005 stated that in seeking to facilitate the development of talented young mathematicians, neglecting to recognize creativity may drive the creatively talented underground, or worse yet, cause them to give up the study of mathematics altogether. So if that's a pretty motivational quote in our group for studying creativity. There are over 100 definitions of creativity in mathematics, and we are going to focus on one of them. So you all will be spared with the other 99 plus. There are also studies of K through 12 creativity throughout the literature. I just cite here Ed Silver's 1997 article and Lycan and Lev in 2013 for a recent example of creativity in mathematics. Sriraman, though, reports that there's a difference between what we would expect K through 12 creativity versus what Sriraman calls mathematical or mathematics creativity. And we say that we side on the more mathematical creativity when we're talking about proving. Finally, Zaskis and Holton wrote an article about creativity in undergraduate mathematics education. It's the only article that we've seen in our extensive research on creativity in undergraduate mathematics education. If you all know of any others, please let me know of that. They also talked about problem posing and not necessarily kind of assessment of how to look for creativity improving, and so we will talk about that today. Our motivation, so I studied 9 mathematicians and 5 graduate students working on proof tasks with unlimited time. I gave them LiveScribe pens, which you all see some data with later on, but not data from this study, from our new study on creativity. I wanted to say that many mathematicians had a break during this research task that I gave them. And that would be considered in the psychology literature and then also in some anecdotal literature from mathematicians as an incubation period. It's one of the 4 stages of creativity. Preparation is getting involved in the problem. Incubation is taking a break. Insight is getting that idea. And verification is verifying if it's true or not. And maybe it is not true. And then Guldan and I interviewed 6 mathematicians, and all of them agreed that creativity is an essential piece of doing mathematics. So if mathematical creativity is enacted and valued by mathematicians, how might mathematical creativity be enacted and valued by our students? Well, our group is under the impression that mathematical creativity should be explicitly discussed with our students. And therefore, we created this creativity improving rubric to discuss those. And I will let my colleague Guldan Karakok talk about this rubric.
Okay. Right, so what we did in our development of our CPR, creativity improving rubric, we used the Sriraman's definition, as a working definition. When you look at this definition, a couple of things that I want to highlight. One thing is process. He's talking about the process. And the other thing that he's talking, given novelty or originality of a solution, and if you look at it in this definition, there is like a posing new questions, coming up new possibilities. And if you again look at this, there's not really a discussion of being correct, right? We don't see that. And what we did is we had this definition, and after that we looked in the literature if there is any creativity rubric out there. So one thing that we found in writing creative writing literature out there. We found one rubric that people were using, but this rubric was not used to give students a score on creativity. In other words, this student's score on creativity is 5. It wasn't used like that. It was used as a formative assessment tool where they were looking at college students' entrance to university and how they start writing their articles. And then at the end, 4th year, they were using the same rubric on their writing assignments and see what kind of improvements they were having. And the other thing in the literature that we saw is Torrance creativity math tests, and the other one was the creativity, Likens creativity rubric. And in this rubric, what was used was 4 important items were used: flexibility, fluency, originality, and evaluation. We're not going to talk about that because we really want you to look at our rubric and how our rubric works on a student process of proving. So I think all of you have a rubric in front of you as a CPR, so you're going to learn how to do CPR today. All right, so you will see that in that rubric, you have 3 pages. Each page talks about a different category. So the very first category that you will see, it's called taking risks, right? So it talks about actually attempts that students are making and their flexibility in making attempts. So each category, each level in that taking risk talks about that. The second page is making connections. So that is about what kind of connections are students making. This could be making connections from representations or previous courses, or any connections that they're trying to make is discussed in different levels of that category. And the third one is posing questions and making conjectures. So I guess that category is kind of like self-explanatory. So what's going to happen next is, this is the IBL part of our presentation. We're going to show you a process, a student proving process, and we will ask you actually to score this proof process using our rubric, and then we will discuss the scores after that. Hussein?
So we have a transcription from student Tang work on theorem 29, which states if 3 divides the sum of digits of n, then 3 divides n. In the handout, you have 3 attempts. The student started this proof on the evening of 2/19, so February 19th. That was his first attempt. And then in the same evening, he continued to the second attempt, which you have a full transcription on the second page. We would like you to go through that transcription of the second attempt and try to grade or score the second attempt according to the CPR. And we're actually going to show you a small clip about his second attempt that we got from his pen, the LiveScribe pen that he was using. So we're going to, I guess, be watching the video. So he started the proof on the evening of 2/19 at 10:37 p.m. That's after his first attempt.
Yeah.
He's writing over there where you see the red dot.
You can put the red dot over there, yeah.
And then on the second day, he restarted the proof or continued the proof in the morning right there. And then he's going to take some short pauses. And then we'll go down to do some scratch work over here. The stuff in the middle is his work on other theorems on a different session. So that was a different time frame.
Let me interject by just saying that all students have the LiveScribe pens with them. I used a generous amount of my startup money to purchase LiveScribe pens for the whole class. And so each student, we got their approving attempts throughout this.
So after he did the scratch work, he moved back again to the proof at 11:29 to continue his proving attempt. Definition S was the definition of division, what it means to have A divides B. And theorem 28 states that if a number divides A and B, then this number divides any linear combination of the two. So now we would like you to try and grade his work, or the second attempt, using the CPR that you have in hand.
So if you have any questions, we will be walking around and could help you with the rubric, or if you have any feedback to us. This is our very first time that we are using it outside our own group, so.
Again, we're not trying to correct, not to grade his correctness.
Right.
Yeah.
I see what you mean.
Yeah.
So mine was trying to say, well,
Okay.
this is, you guys can you use this?
The transcript. You wrote it as if and only.
So I heard that you said.
So I can understand, like,
He's writing
explain to me
all
what
that.
I started.
So if it's possible, could you guys, could you assign a score or a grade to this attempt using the CPR? And would you be able to give us some feedback on your scoring for the second attempt? And we also would like your feedback on how would you incorporate or utilize the CPR if you're going to use it in a teaching practice, whether it was a transition to proof class or a different IBL setting.
So can anybody come on up to the mics and share what they scored each of the 3 categories for this attempt? And if not, why could you not score them?
Yeah, what's
That's
wrong
a
with our
great-
rubric?
No, I worded it a little bit nicer than that. But yeah, if you couldn't score it, what were the challenges of scoring it? What's that? Time. Yeah, absolutely.
Yeah.
You also are getting a skeleton of, you got a 2.5-minute quick clip of what he did, and we watched the clip of what he had done for a while, all the way through. So we also caught all the pauses and all the breaks and everything else.
So the table back there, the one that I talked to, had some ideas. Could you, one of you, could you please share us what you were saying about the rubric, some ideas that you observed?
Absolutely. Please.
Yeah, please, thank you. Sure.
Or we'll take it to you.
Hi, I'm Allegra. We had been asking the question about the transition from developing to satisfactory. In fact, we were kind of getting caught up in the first page, and we realized, had we looked at the second page's qualifications, we saw that as maybe really the axis of creativity and the thing we most expect to see in a mathematician initially. And so maybe that was what caught us up. But we had noticed that there seemed to be such a delineation between a developing person and taking risks and a satisfactory one. In fact, it was almost frightening to us as to how you could say developing about what was put in the rubric in that category, because what is the risk they're taking other than telling you everything they know? If you look at the idea of saying we're going to provide related arguments, the question is how related are they? And so there was sort of this refinement. And we had the conversation about, well then, if that's developing, which I think is an important step that you have to get through, especially attacking a problem you might not understand, then how do we get from there to satisfactory without satisfactory meaning it's correct? And if there was some sort of in-between point. And so we had this long debate about that and never even finished evaluating the student. But we think page 2 should be page 1.
Okay. Okay. Any other comments or questions or thoughts on the rubric or on scoring the student? Yeah. I think we're going to go with John Paul first and then over here.
So I was wondering the thoughts that you all have on using this rubric outside of a setting where all of the students have live scribe pens and you have access to all of that.
Yeah.
All of that data. Obviously, that's a great advantage to be able to go back and see their process. And I asked Hussein about this a little bit, and there are some things that you can do, but some of the items that we saw in the rubric seemed like they required some kind of insight that you might not normally have on maybe a typical homework assignment. So I was wondering how you would recommend accounting for that to someone who is interested in using this.
Oh, that's a great question. We will answer that after we get this question.
I was just wondering about, did you take under consideration if these students were all at the same stage of knowledge? For example, if someone had seen this question before, then, attempting or trying right away or solving it right away will be different. It's not a creative thing for him or, whereas if he has not seen it before, it definitely will be a different measure. So has this been taken under consideration?
So I guess a disclaimer. Should I disclaim that I taught the course?
Yeah.
Okay, anyways. So I would claim that every one of, or almost every one of my students had seen that theorem before, maybe in 3rd or 4th grade, but had never thought of why adding up the digits and dividing that would mean that the whole number would be divisible by 3. Now the proof though, at least, this is just me observing what they attempted, I found that no student had a notion of how to prove it. In fact, multiple students had more than one proving attempt, which, by the way, is just phenomenal in its own right. To have students double back and say, oh, shoot, this is not good, let's try another one. So I thought that was very interesting, but I would say little to no knowledge of the proof of that theorem was. But coming back to John Paul's question, we have Molly here who will discuss the kind of teaching strategies we would suggest for using the CPR, even if you do not have the LiveScribe pens.
Thank you. So as Milos said, we have some recommendations of how to utilize our CPR in your classroom. Our first recommendation is setting up the environment in the classroom. In math education, we call this the socio-mathematical norms. And what we mean by this is it's important to discuss and demonstrate proving attempts and emphasize that mistakes can help students in the proving process and in learning how to prove. It's also important to pose theorems that require multiple solutions and to assign conjecturing tasks in the homework. And with these two suggestions, it's really important that we as the instructors assign problems that allow the students to do this. Some problems and some proofs are, follow your nose proofs, and they're pretty straightforward, but that's not very conducive to using our rubric, and it's a lot more interesting and valuable to the student and the instructor if we assign these sorts of problems. Our second suggestion is to use the CPR when students are demonstrating or presenting proofs in the classroom. An example of this would be if you have a student at the board presenting, you could comment and say, wow, I can really see that you're improving in the posing questions and conjecturing section. You're asking questions that lead to investigative ideas, great job on this. So you can just kind of promote the student's creativity in this situation. In conclusion, we think that an IBL setting is optimal for using our rubric. But who cares what we think? Let's hear about the students. I interviewed the students, and we asked them if they felt that an IBL setting was more conducive to creativity than a traditional lecture style. Student 15 said, this course is definitely more conducive to creativity than a traditional course structure, in that I cannot turn my homework in Calc 4 and have the wrong answer written down and get credit for it. I think that's probably pretty telling that I'm talking about credit rather than the learning process. But as far as learning things go, there is not much creativity in the things that I've learned previously. And student 11 said, I would say absolutely so. Just, the setting itself lends to creativity because we're being forced to be creative. He even chuckled at the end. These are our references. They're rather tiny. But if you have any questions, this is how you can get a hold of us. Thank you.
So I just want to reiterate the point that Molly made. When you are in the classroom in an IBL setting, there are chances that you could have students co-create proofs up on the board. Then you can see their proving process and therefore utilize the rubric in that respect. So John Paul, there are opportunities other than with the LiveScribe pens to do that. I was fortunate enough to have both opportunities, both them presenting in class with co-creation and the LiveScribe pen data. We do have, I brought LiveScribe pens if you all want to try them out, and I brought the actual paper that comes with it too. So just in case.
The other thing that we want to highlight, this is, our plan was to use this as a formative assessment tool, like inform students where they are and what they're doing in terms of creativity, kind of pushing their limits a little bit. So that's why we had all these different categories from beginner, developing. We still don't know if that satisfactory work is a good one, but so that's what we intend to do with this rubric.
Any questions, comments, musings, frustrations?
Just to follow up on that last question, Dale Oliver, Humboldt State. Have you talked about using this in a sequence of courses so that you provide some feedback to the programs that you're running about the development of students along the way?
That would only happen if sequences were willing to use it, right? Or if programs were willing to use it. No, we haven't thought about that yet. We actually, what's crazy, we have an idea jar, we call it, in our OneDrive folder, and we just throw ideas down there that we want to either research or explore. And I think that idea of using it, either using it consistently or using it as an evaluation tool would be phenomenal.
Annie Selden, New Mexico State. Was this ready in time, so in this class you had the students self-evaluate or not?
Yeah, so it was not ready. And we actually had to use some of the students' data to further refine the rubric. Because after observing and scoring, we felt that we were not incorporating as many categories. Also, at the end of the class, or towards the end of the class, Molly interviewed 7 students, and from those we actually got a little bit more refinement into the rubric. So I intend at least on using it in the, well, we call it discrete mathematics, but I mask it as transition to proof course at OU for this fall. I intend to actually weight it with a certain grade percentage, whether it be 5 or 10%. And we'll see if they value it as much as I'm going to give them a grade for valuing it. So, yes.
Daniel Kiddick, Indiana Wesleyan University. What were the name of the special pens? I'm sorry, what was special about them?
Okay, so they're, I'm sorry, I'm usurping every question. They're LiveScribe pens, and what they do is if you turn them on, and there's a button on the bottom that you hit with the pen that has record, and when you write down anything, not only will it incorporate what you say into the pen, but it'll incorporate when and where you write down your words on the pen. So for example, you saw the student hop down to the bottom and write down on some scratch work, like 3 to the 6 equals 9 to the 3rd, right? We wouldn't have known that if we were to just get his work in particular, because we would, as most evaluators do, read the proof line by line, top from bottom. It was really nice to see that there was a motion of going down, working a little bit, and then coming back up, because it enhanced what the student was thinking of at the time. So there's also paper that's associated with it. The pens that I bought were on sale, so I got a little bit of a nice discount, but they're usually $120 and above. Now that I have them, and 98% of the people returned them, crazily enough. With sophomores, I don't know, that's a gamble a little bit, but I'm going to incorporate them into every transition to proof course I teach, or proof-based course. I'm actually angling to get an abstract algebra and a real analysis course to teach at the school. Thank you.
Thank you.
If you have any other questions, please email us at the 8,000 emails we put up on the screen. Please let us know if you'd like to use the rubric in your classroom. We'd like to hear what went well, what went wrong.
Feedback on it.
Yeah. So, thank you all.
Thank you.